Welcome to my YouTube channel. To all of you, my returning subscribers, thank you very much for your support. You guys have been awesome. And if you are dropping by for the first time, please like this video, hit the subscribe button and strike the bell notification. That way you will be the first to know whenever I post interesting stuff such as this one. Thank you very much as you do so. In this video, we are going to see how to load VPC flow logs into Amazon S3 and then query it with Amazon Athena. Lots of services involved here. Of course, we've got the VPC flow log, we've got the VPC itself. We're going to be talking about Amazon S3. We're going to attach policies to S3 that allows our flow logs to, of course, be loaded into Amazon S3. We'll talk about AWS Glue, and of course, we're going to be wrapping up with Amazon Athena. We'll see how to run queries that's going to be accessing the flow logs from S3, of course, using Athena. This promises to be a very, very interesting session. This is one of those sessions you don't want to miss. I guarantee you would have learned something new at the end of this video. So stay on and watch till the end. It promises to be a very rewarding session. Thank you very much as you do so. We're going to be looking at how to load VPC flow logs in Amazon S3 and then see how we can query it with Athena. So let's begin. We are going to introduce all of the services. We'll begin with Amazon VPCs. We'll move on to VPC flow logs. We'll talk about S3. We'll go on to Glue. We'll talk about Athena, and we're going to see how all of these things come together. So let's get started. Now, in today's cloud-driven world, network security and operational visibility are crucial for maintaining efficient and secure infrastructure. And the VPC flow logs provides insights into network traffic, allowing organizations to not just only monitor, but also to analyze and troubleshoot connectivity issues across all of their AWS environments. But effectively monitoring and querying these logs requires us to be systematic in our approach. And we will be leveraging all kinds of services. And in this video, I explore how to load VPC flow logs into Amazon S3 and then query the logs using Amazon Athena, which is a cost-effective and serverless analytics solution. So we're going to be integrating these services together. And by doing so, we will be able to transform raw network data into actionable insights, which will in turn enhance our security monitoring efforts, will allow us to detect anomalies, and of course, make us overall operationally more aware. So let's begin with the Amazon VPC. Now, at the very basic and at the core, a network is just a collection of connected devices that can share information under specific rules. And in the AWS world, the Amazon VPC is your ability to create a private and isolated section of the AWS cloud. That is your very own virtual data center. What this isolation means is that though you are running within the AWS massive shared infrastructure, your resources can exist in an environment that only you can control. So what are the essential elements of this network? First, there is isolation. And by design, a VPC allows you to carve out a private space within the cloud, ensuring that your compute instances, your databases, and other services remain separate from other users' resources. Then, there's control over connectivity. That is because a VPC allows you to define your own IP address range, to create subnets, and to segment resources, both public-facing and private, and then to set up things like routing tables, internet gateways, and NAT gateways that direct traffic exactly how you want them to be directed. And then security is inbuilt. You can use security groups and network access controllers that allows you to enforce stringent controls as to how your network connections should be allowed or disallowed, which will allow you to protect your assets from unwanted exposure. Now, all of this control is essential for a number of reasons. Again, the first one is security and isolation, because it minimizes the risk of unauthorized access and resources in different subnets could be isolated, and you can define granular rules to control how your traffic flows. And then you can customize your network architecture just like you would design a physical office layout to suit your team's needs. A VPC allows you to architect your cloud environment with the right balance between public and private services. And then a lot of organizations might need to bridge their on-premises infrastructure with cloud resources, enhancing hybrid connectivity. And then the VPC provides secure integration via constructs like virtual private networks or AWS Direct Connects, which allows connectivity that is secure between your data center and the AWS cloud. And features like the VPC flow logs will help monitor traffic, giving you insights into network behavior, which is fundamental for troubleshooting and even forensics. Now, we see here that the VPC is not just another AWS service, it is the foundational fabric that controls how resources communicate, how they stay secure, and how they are integrated within and beyond the AWS cloud. So, enough of this talking. Let's dive into the AWS console, see how to create a VPC and all of the essential components within the VPC. Okay, so we are in the AWS Management Console. That's the console home there. And we want to embark on the process of creating a VPC. We've been discussed the details of what a VPC is. We now want to go ahead and put into practice some of the things we talked about. So I'll go ahead and click on VPC. And we load the VPC console. I want to ensure that I'm in my default region. And usually there would have been a default VPC here, but I've deleted it. And that's because I want to go ahead and create everything from scratch. So I'll just go ahead and hit on create a VPC right here. And I want to create the VPC only. But so you know, you can create the VPC and other components here. But of course, I want to create them in a step-by-step basis to give you more clarity into exactly what's going on within the console. So I'll just create the VPC only. I'll give my VPC an optional name, even though giving the VPC a name is optional. I strongly recommend you go ahead and name your VPC appropriately. And I'm going to call my VPC demo Athena VPC, for example. And I want to go ahead and define the CIDR block. Now, the CIDR block is very important. It basically gives you the range of IP addresses that you are going to have for your VPC. I want to give my VPC a class B private IP address. So I'll give it 172.31.0.0/16. What that simply means is that I'm going to be using half of the octets as the network component of my CIDR block and the other half as the host component. And that's just what it means. So I want to make sure that my tenancy is default, but so you know, there are options like dedicated, which I'm not going to use in this case. Tagging is also optional. Basically, a tag is a key value pair that allows you to, to define some attributes for whatever service you are naming to allow you to search through it and to better manage it appropriately. But this is all I want to create here. I'll just go ahead and hit create VPC, and my VPC is created. So if I go back to my VPCs, we can see the VPC I created. And if I go ahead and click on this, we can see all of the details that I had defined. Not very much, but I want to go ahead and do the next thing, which will be now to create a subnet. I want to create two subnets. One will be public, the other is going to be private. So I'll go ahead and click on create private subnets. And you see here that it prompts me to attach the subnet to a VPC from the very get-go. I just go ahead and specify the same VPC I created earlier on. So I'll go ahead and click on this, and it gives me options. I'll go ahead and define my public subnet first. So I'll just call this public subnet. And then, of course, availability zone. I'll define one of my availability zones as the preference. And then, of course, I'll go ahead and specify the CIDR block for my subnet. I'll go ahead and, for example, define this as my CIDR block. And again, it tells me that I've got 256 IPs for this specific CIDR block. What that means is this. My subnet should be able to host up to 251 IPs. Why 251 and not 256? That's because 5 of the IPs will be reserved by AWS for a number of other services. So I'll go ahead and create my subnet. And if we come here and refresh, we can see that we have a public subnet created. Then I want to go ahead and create a second subnet, which I'll still attach to VPC. This time I'll call it private. And then I'll specify another availability zone. And then I'll go ahead and specify another CIDR block. Okay, and again, we see we have 256, but again, like I said earlier on, the addressable, I mean, the useful addresses will be just less 5 of this. So it's going to be 251 that's going to be available. I'll go ahead and create the second subnet. And if I come here and do a refresh, just refresh again. Okay, yeah, we see here that we've got 2 of those subnets are defined. So I've defined my public, I've defined my private subnet, and then of course the next thing I want to do is I want to go ahead and enable my public subnets to be able to automatically assign IP addresses. So that's my public subnet there. I'll go to actions, I'll go to edit subnet settings, and I'll just come and check this box here, auto assign IP settings for my public subnet, and then I'll go ahead and click on save. Now, enabling auto AWS, by doing this, I'm going to be enabling AWS to automatically assign a public IP v4 or v6 address to a new primary network interface for an instance in the subnet. So I'll go ahead and save this, and my subnet is now ready to be able to receive an AWS address within the public space here. Okay, now what actually defines a public subnet is not just naming the subnet public. Now, what makes the subnet public means that any address that cannot be resolved within the public IP, within the IP address range in the subnet, is got to be sent somewhere. And that somewhere it is sent is the internet gateway. So that's going to be the next thing I'll go ahead and create here. You can see that I do not have an internet gateway. So I'll go ahead and create one. So I'll go ahead and click on create internet gateway. I'll give my gateway a name. I'll call it demo Athena gateway, for example. And that's all I'll do for now. I'll just go ahead and create the internet gateway. We can see that we now have an internet gateway created. So I'll create the internet gateway, and right here I can attach it to the VPC. So I'll go ahead and click on attach to VPC. I'll select the VPC, and of course I'll go ahead and attach my internet gateway. So the internet gateway is now attached to the VPC. Now, but that's not all. I've got to have a means of sending traffic that is not that's not supposed to be within the subnet to the internet gateway. And to do that, I've got to go ahead and create a route table. So I'll come here and go to route table. We see that there is a route table created already. We can see I've got a route table here. So I want to go ahead and select the route table. Now I want to specify a subnet association. Now we can see here that we have our route tables associated both with we have public and private route tables associated here. So we can go ahead and see, edit the subnet associations, and I want to associate my route table with the public subnet. So I'll go ahead and specify the public subnet, and I want to go ahead and save the association. So my route table is now associated with my public subnet. Now the next thing I want to do is I want to create a route. Now creating a route will mean that every traffic that is not local should be sent to the internet gateway, and those rules I want to define within my route table. So I'll go ahead and add a route. And I would say any traffic here that is supposed to go to the internet should go to the internet gateway. And I'm going to specify the name of my internet gateway, and then I'll go ahead and click on save. So right now, what I have done is that if there is any traffic that needs to go to the internet, okay, within my public subnet, then of course it's going to be forwarded to the internet gateway, and the internet gateway will know exactly what it should do to such traffic. Now, another thing I want to go ahead and do is to create a security group. So I'll just click on security groups, and then I want to go ahead and take a look at the default security group that has been created already. We've got inbound rules and outbound rules, but of course I want to go ahead and create a fresh security group. So I'll go ahead and click on security group, and I'll call it demo Athena SG, for example. And I want to give a description. I'll just say allows SSH and HTTP traffic from the internet. For example, I want to attach it to my VPC, and I want to specify an inbound rule. I'll go ahead and add a rule. I want to say any the type of traffic should be SSH, for example, and if it's coming from the internet, it should allow that. Now I want to go ahead and define another inbound rule. This time around, I would say maybe HTTP. So I'll go ahead and specify HTTP, and if it's also coming from the internet, I want it to be allowed. And then I'll go ahead, and I've done two things in one go here. I've created the security group and also defined the inbound rules for the security group. So I'll go ahead and click on create security group. Now, next thing we're going to be talking about is Amazon S3. So what is Amazon S3? Now, at its essence, every system that is robust will need a place to hold data in a way that is reliable and accessible. And Amazon S3, which is short for the Simple Storage Service, does exactly this by giving us a highly scalable and durable object storage solution. Now, instead of treating data as low-level bits on disks, what S3 does is that it organizes your data as discrete objects, and each object is stored inside a bucket which has a unique key that makes retrieval straightforward. And this takes away the complexity of managing the underlying hardware, because S3 is a fully managed service that allows you to focus on your data and your application rather than on all of the different undifferentiated heavy liftings. So within our architecture, where we load VPC flow logs into S3 and then query it later from Athena, S3 plays a very important role as the centralized repository for our raw log data. And the VPC flow logs generate a continuous stream of records capturing network traffic metadata. And by loading these logs into S3, we have a number of advantages. The first advantage is durability and scalability. And that's because S3 is engineered to give us 11 nines of durability. What that means is that your log data is resilient even as it grows to terabytes or even more. Now, the next thing is it is cost effective, because we've got a pay-as-you-go model. That means if you store vast amounts of data, you don't have to pay anything upfront as you would do within a traditional storage system. And S3 can also act as a data lake. And by doing so, it can seamlessly integrate with other AWS services. In this case, it can specifically integrate with Amazon Athena, meaning that Athena can query your log data directly, separating the storage and the compute, giving you some flexibility and efficiency when it comes to processing and analyzing your data. So why is all of this important? When we think about storing data, there are few things that come into mind, such as reliability, scalability, and ease of integration. And S3 meets all of these requirements. Uh, it, it is an infrastructure that automatically replicates data across multiple facilities, ensuring that your logs remain intact even in the face of hardware failures. So it is a reliable solution. Now, whether you are dealing with a few megabytes or petabytes of data, S3 scales horizontally to accommodate growth without any degradation in performance. And again, by providing a uniform interface for you to retrieve data, it allows tools like Athena to perform on-demand querying, turning log data into actionable insights without performing any complex ETL or extract, transform, load processes. And of course, with fine-grained access control and encryption features, your data remains secure, underpinning robust compliance frameworks. So, S3 is much more than just a storage service. It is the backbone of our log analytics architecture because it is resilient, it is scalable, and cost effective. Being able to store our VPC flow logs. And it preserves the raw data and facilitates real-time analytics and troubleshooting through services like Athena, which makes it indispensable for a modern and secure cloud infrastructure. So we're going to go into the console once again. We're going to see how to create this S3 bucket, and we are going to apply the appropriate policies that allows just what we want to happen at the bucket level. Again, stay with me as we move into the console to do just that. So we are going to be looking at how to create an S3 bucket and attach a policy that is going to allow us to write VPC flow logs to the S3 bucket. So to do that, we will go to the Amazon S3 console. So I go ahead and click on S3 here. And we want to create a bucket. I'll go ahead and select general purpose bucket. And I want to create a bucket. So I'll create a bucket. And I want to call the bucket demo Athena VBA bucket, for example. Okay, so we'll go ahead and create the bucket. The only setting I'm going to have here would be to block all public access. I'll just uncheck that. Now, the reason for that is this. An S3 bucket is one of the services or one of the resources in AWS that does not sit in a VPC. So in this specific case, we want to be able to write to the bucket through the internet. So one of the things we are going to do is to uncheck the block all public access, because by default, every S3 bucket that we create is private. But that's not going to be sufficient. As we move on, we are going to now attach an S3 bucket policy to the bucket to allow us to be able to write our VPC flow logs to the bucket. So I'm going to go ahead and acknowledge that the current setting might result in bucket and objects becoming public, which is exactly what I want. And then I'll go ahead and create the bucket. So I'll click on create the bucket. And our bucket is created. So that's our bucket there. And currently our bucket is empty. Okay. The only thing I want to do right now is I want to go to the properties and I want to copy the bucket ARN. And that's going to be very important shortly. So I'll go ahead and click on this to copy the ARN of the bucket, and I want to go ahead and paste it somewhere because it's going to become quite useful very, 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 very soon. So I'll go ahead and have it pasted. So the next thing I want to do now is I want to go to the policy of the bucket and, for example, access the bucket policy. Okay, so I'll click on the bucket and go to the permissions tab, and then we're going to come here and go to the bucket policy. I'll go ahead and click on edit, and of course we want to edit the policy that is associated with this bucket. So I had created a policy. I'll just go ahead and copy the policy, and I'll go ahead and paste the policy right here. So we have put in our ARN for the bucket, and the next thing I want to do is I want to go ahead and save. Okay, so we've saved, and for now that is the only thing we are going to be doing in the bucket. We are going to go back to the VPC console, and then we are going to go and enable the VPC flow log. So, what are VPC flow logs? At the foundational level, every network consists of data packets, and these packets travel between devices. To manage and secure these flows, you will need to know what is happening, who's connecting to whom, when is the connection taking place, and how is it happening. So VPC flow logs serve the purpose of keeping tabs on what's going on within your network at the VPC level. And rather than capturing the full payload of every packet, which will be both resource intensive and overwhelming, the VPC flow logs capture the most essential aspects of these flows. In other words, it captures the metadata about each network flow. The details it captures will include things like the source and the destination IP addresses, the ports and the protocols, and whether the traffic was accepted or denied. So in essence, they provide a summarized log of the network conversations that is taking place within your cloud environment. So how do they fit into our architecture? Now, loading VPC flow logs into Amazon S3 and then querying them with Athena, the flow logs themselves are the raw data source. They capture the ongoing communication within your VPC, which is crucial for monitoring and troubleshooting your networks. So why is this important? That is because effective decision making is grounded in accurate and timely information. And VPC flow logs provide a clear picture of your network's behavior without delving into every packet's finer details. And this is important for a number of reasons. First, they allow you to spot suspicious activity and potential intrusions by tracking unusual connections or traffic patterns, so they enhance security. And also, for troubleshooting, when communication or connectivity issues arise, the flow logs act as a historical record, helping you to pinpoint where, when, and why the problem occurred. Then, for operational visibility, they will give you insights into the performance and the usage of your resources, facilitating better capacity planning and network management. And for compliance, of course, maintaining a flow log or maintaining a log of network traffic is usually a regulatory requirement, which will ensure that you can audit and verify the flow of data across your environment. So we see that flow logs are foundational to understanding and managing your AWS network environment because they give a filtered and high-level view of your network traffic, which will in turn allow you to harness the full potential of integrated services like Amazon S3 and Athena to give you a comprehensive, real-time analytics and security monitoring. So we're going to go into the AWS console and we're going to see how to enable VPC flow logs for the VPC we created in the previous section of this video. So stay with me. So we had earlier on created the VPC. So the next thing we want to do now is we want to create a VPC flow log. And to do that, we'll go to VPC. and we'll go to my VPCs. We can see the VPC I created earlier on. I want to go ahead and access the VPC, for example, and we can see all of the details of our VPC right here. And I want to go to actions. And of course, we have all of the details here. So from actions, of course, I can go ahead and see the option to create a flow log, which is the very first option here. So I'll go ahead and click on create flow log. And we see the option to create a flow log. We see the selected resources. We can go ahead and give our flow log a name. I always like to give it a name. So I'll call it Athena flow, logs, for example. So we'll just give it a name. And it gives us options here telling about filtering, the type of traffic to capture, accepted traffic only, rejected traffic only. But of course, I want some level of detail here, so I just stay with the default, which is to capture all traffic. Now we've got the maximum aggregation interval here, which is the time during which the flow of packet is captured and aggregated into a flow log. 10 for me is a bit too wide. I want to narrow it down to 1 minute. I'll just go ahead and click on 1 minute. And then there is very important, the destination. So the destination here is, we can see, send to CloudWatch logs, send to S3 bucket, send to data firehose in the same account and in another account. But of course, what we've got here is to send to an S3 bucket. And here we want to go ahead and specify the ARN for our S3 bucket. So I'll go back to where I kept the ARN, and I want to go and copy that because it's going to be the parameter I'm going to plug in there to ensure that I can configure what I wanted to configure appropriately. So I'll go ahead and copy that, and then I'll come and paste it here, and we see the ARN is there. So we've put in the ARN. We'll just look through all of the options. For the log format, we've got default format, which is what we are going to choose. But I'll just choose on the custom format, and then we can see the format we've got. We can see we've got a lot of different options, which I'm not just going to go into. I'll just leave it and go back to the default format here. So we see all of the details for log file format. We've got the options for text, which is the default. We also have options for package, which is a compressed format. I'm going to stay on and stay with the default. And of course, again, we see the options for tags. I'll just go ahead and we see we have the key, which is the name. And then the value for the name is what I specified at the beginning, which is Athena flow logs. I'll go ahead and click on create flow log. And of course, our flow log is now created. All right, so we have installed the VPC. We've enabled the flow logs. We've even gone ahead to install an EC2 instance. And the aim of the EC2 instance is for us to be able to generate some traffic within the EC2 instance that is in the VPC. And that traffic should be captured within the VPC flow log and sent to the S3 bucket, which we've created just for that. But before we can create any traffic or can generate any traffic, there are a couple of things that we've got to do within the EC2 instance. So I'll go to the EC2 instance. I'll click on it. And I want to connect to the EC2 instance. So I will select the instance and I'll just click on connect here. Now there are a number of ways we can connect. I want to use the EC2 Instance Connect. But of course, you can see we've got other ways. Specifically, we've got the possibility of connecting using the SSH client. And of course, we've got the steps there. And we could all just go ahead and run this command within a command shell, for example. But to keep it simple, I'll just go to the EC2 Instance Connect. And I want to go ahead and click on Connect. So it opens up another tab within the browser and it attempts a connection. Remember, at the point where we're creating the security group, there are a number of things that we had enabled within the security group that's going to allow us to connect to our EC2 instance via the secure shell. So the first thing I want to do is I want to switch user. I'll go ahead and, for example, run the sudo su command. The other thing I want to do is I want to now, of course, run the appropriate update commands. Okay, so that's the yum update command. That's going to, of course, tells us that there are no packages marked for update. I want to now install the HTTP daemon. So a similar command there, the yum install HTTPD. I'll go ahead and have that installed. So of course it does its thing. And the next thing I want to do is I want to switch the directory to the var www HTML directory. Of course, that is switched. And the next thing I want to do is I want to write to that directory. Specifically, I want to write to the index.html file that is within that directory. So I want to echo this is coming from the Apache server on the internet, which I want to, of course, write to the index.html file that is in the var www.html /html directory. So I'll go ahead and run that, and that is done. And then I want to start the HTTP daemon. I'll go ahead and start that. And then I want to enable. And then I want to check the status. Okay, so let's look at the status. And it tells us, of course, it's running. It tells us from when it started running. It tells us about 25 seconds ago. Of course, roughly about the time we ran that command. So another thing we want to do is we can go to the public IP here. I'll just close this too. And then from within the public IP, we can see the same thing we wrote. This is coming from the Apache server on the internet. I'll just do a zoom here that's going to allow us to see it better. Okay, so we see that's the exact thing we wrote that is available. So of course that means our HTTP or Apache server is currently up and running. That's exactly what we want. So we will move on to the next steps. So we've created a VPC, we've enabled a VPC flow log, we've created our S3 bucket, we've applied the policies at the bucket level. So the next thing we want to talk about is we want to talk about Amazon Glue. So what is Amazon Glue? Now, the fundamental level, data is information in raw form. We already said that. However, raw data is not immediately useful until we've extracted it, we understand it, and we know the structure. So glue is a fully managed serverless extract, transform, and load service. And glue allows us to extract our data, in this case, of course, from Amazon S3. Okay, so it automates this process of ETL, which can be cumbersome. It automates the process of discovering data, of inferring schemas, of cataloging metadata, and transforming unstructured or semi-structured data into a format that is ready to be analyzed. Now, I want you to think of it as the glue that binds disparate data pieces together, which is going to be ensuring that all of the components are coherent, accessible, and ultimately queryable. So, within our architecture, we've got the VPC flow logs streaming raw data into Amazon S3 for durable storage. But before we can efficiently query this data with Amazon Athena, we need a clear understanding of the structure of the data, and that is where Amazon Glue comes in. That's because Glue can automatically scan the data that is stored in S3 using crawlers. It can deduce the schema and then populate a central metadata repository known as the Glue Data Catalog. Now, this catalog acts as a reference layer, translating log entries into a structured format that Athena can interpret effortlessly. So, in essence, Glue bridges the gap between unorganized log files and structured query ready datasets. So, why is this important? Again, effective decision making relies on having clean, organized, and readily accessible data. And without these steps, querying unstructured logs becomes inefficient and prone to errors, which can make it difficult to derive meaningful insights. And Glue is crucial here because it automates data preparation by handling tasks like schema inference, data cataloging, and transformation. And it does all of that automatically. And by doing that, it significantly reduces manual efforts and the potential for human error. It also enhances query performance, having a well-maintained metadata catalog, allowing Athena to directly reference the organized data structure, which is going to lead to a faster and a more accurate query. Again, as your data set grows with accumulating VPC flow logs, Glue's serverless architecture ensures that the data preparation process remains robust and efficient without the need for managing the underlying infrastructure. And it also integrates deeply with other AWS services, such as S3 and Athena, forming a cohesive pipeline that transforms raw network activity logs into actionable business intelligence, security insights, and operational metrics. So we see that Glue plays an important role in our architecture because it transforms messy raw log data into a structured and manageable format, which will enable seamless, cost-effective querying with Athena, which will in turn ensure that we can derive maximum value from the underlying data. So we are going to go again into the console and we're going to see how we can add Glue into our list of services and how we can enable all of the necessary things that we need to enable so that it works perfectly. Stay with me again as we get into the console. So next we are going to be working with Amazon Glue, and within Glue we are going to perform a number of activities. So let's just go straight to Glue. I'll do that by clicking on Services, going to Analytics, and scrolling down. And I'll go ahead and click on Amazon AWS Glue. So we are in Glue, and I want to do two things amongst others. First, I want to create a database. So I'll come here to Data Catalog, and I'll click on Database. I want to add a database. I'll enter a name for my database. I'll call it Athena DB. That's the name I want to give it. Of course, we have an optional description which tells us that we'll be using lowercase only. So I'll just change this to lowercase, and we've got an optional description. I'll say this is a database for my VPC flow logs, for example. And I'll go ahead and create the DB. So I'll go ahead and click on create DB. So we have the DB created right here. So I can, of course, go ahead and after I've created the database, I can go ahead and again on the data catalog, I'll go ahead and create a table. So I'll go ahead and click on add table, and we can specify the table credentials. Of course, I'll specify the DB. I'll call this, I'll just call it Athena table. Right there. And I can specify again a description if I wanted to. I've selected the database, and here I want the data store to be S3, and from S3 here, of course, I can go ahead and include a path. So I can browse, for example, and that's it there. We've got a bucket. I'll go ahead and choose, and it tells me that I have to do a bit more. I'll just put a slash there, and that should solve all of those challenges. Now, the next thing we want to do is I want to specify data format. Under data format here, I can go ahead and select the comma separated volume, and we have the option to choose a delimiter, for example, and then I'll click on next. The delimiter here is comma, but so you know, there are other kinds of delimiters that we could choose. So I'll go ahead and click on next. And for here, it takes me to the schema where it prompts me to define or upload the schema or choose from the schema registry. I want to go ahead and edit schema as JSON, and I want to go and include a schema which I had pre-created. So I'll just come in here and specify a schema. Okay, so we can see we've got the name, the version, of course, the name, the type. In this case, we'll specify the name as version and type as string, name as account ID, type as integer, and so on and so forth. So I'll go ahead and click on save here, and we can see the details that we've got. And I'll go ahead and click on next. I'll leave everything the way I've created it, and I want to go ahead and click on create, which goes ahead, of course, to apply everything that we have done. So that's about all of the activity that we are going to be doing here with AWS Glue. The next service we will talk about is Amazon Athena. Of course, as data becomes truly valuable, only when we can gain insights from them, like we said before. So Athena in this case is a serverless and interactive query service allowing you to analyze data directly in Amazon S3 using the standard structured query language. And instead of provisioning or managing any servers, Athena is going to allow you to, of course, query your data in S3, and it can automatically scale to meet your needs while you pay only for the queries that you run. Now, this simplicity empowers anyone from a data analyst to a security professional and allows them to immediately interrogate their data to be able to get the appropriate and actionable insights. Now, in our use case, VPC flow logs continuously record the traffic data generated within our VPCs, and these logs are sent into S3 where they are accumulated as raw data. However, like we also said, raw data, like a vast library of unorganized nodes, is only useful if it can be read and understood. So this is where AWS Glue plays its part, and it does that by automatically crawling the data in S3, deducing the schema, and storing the metadata in the Glue catalog. It transforms those catalogs into a structured format. And then Amazon Athena leverages this organized metadata in the Glue data catalog to run interactive SQL queries. So whether you are troubleshooting a connectivity issue or investigating a potential security anomaly, Athena lets you slice and dice your log data in real time. Of course, the serverless nature means that you can scale your analysis effortlessly without worrying about infrastructure overhead. So, effective decision making is going to now hinge on access to timely and structured information. And Athena is important because of ease of access, allowing you to directly work with data that is stored in S3 without the need to move or transform the data manually, allowing you to focus on querying and analysis. Its pay per query pricing model means that you only incur cost when you actually run a query, making it both economical and scalable. And it automatically handles the complexity and the provisioning and scaling of compute resources, meaning that as your data set grows, your ability to query it in real time remains simple and robust. And by integrating natively with AWS Glue, Athena ensures that your structured metadata translates into meaningful query results, providing clarity from your unstructured logs. So again, we will get into the console. We'll see how to work with Athena. And of course, we'll run a number of queries before we come in and summarize all what we have been talking about. Okay, so we are going to be looking at Athena again. To launch Athena, we'll go to analytics, and there we are. Athena is the very first option we've got. So I'll just click on it, and that opens Amazon Athena. Just to give us a complete view here, we can either come to launch the query editor from here, or we can come here and select query editor, whatever we want. I'll just go ahead and click on launch. We'll click on settings, and of course we've got the option to see we can manage. It prompts us to browse. I'll go ahead and select my bucket, and I can, for good measure, just come and move on to the specific part of my bucket. So I'll just go ahead and type AWS logs. And if, of course, we are not running this from the same region as our account, we can enable this, which grants the owner of the S3 query results bucket full control over the query results. So just for good measure, I'll just go ahead and hit on this and go ahead and click on save. So we have it there, and we are now ready to begin to run our queries. Now we're going to run a few queries, and if you got some familiarity with SQL, you're going to see that the queries are pretty similar to standard SQL queries. So the first query I want to run here is going to return the overall number of flow log records. So I just go ahead and indicate this. See, it selects account, and it aliases it as total records from our Athena DB, specifically our Athena table. We could do an explanation here if we wanted to, but I'll just go ahead and run this. And it's running, and it gives us, see, in the few minutes we've got quite the number of logs. We have a total of over 480 logs from when we enabled our VPC, and we started generating traffic. So see, quite a number, and this has been just a few minutes. So imagine what can happen if you have this up and running for days. Okay, so the next thing we want to run some more queries. We want to find the top 10 source IP addresses by total bytes. Of course, so we want to go ahead and run this. I'll go ahead and run. And here, of course, we see that this is coming, it's coming from one address. So there's just one source address, and we have the flow count right here. Okay, so we have a lot of things we could do. For example, we could identify the top destination IP addresses also, which I'm going to just run here. This query gives us the top destination IP addresses. Let's go ahead and see what the result will be. And again, one destination IP address is what is going on here. So there's not so much for us to worry about. We could also aggregate traffic by protocol. So we want to go ahead and look at the distribution of traffic across different protocols. And to do that, we are going to be using a specific query here. I'll just go ahead and paste that, and that's what this query does. I'll go ahead and run. And again, not much, of course. So there are lots of things we could do. We could analyze and do all of those things. We could look at the flow actions, and maybe we should just take another example to see the actions, like the accept or reject actions, which is going to allow us to understand the ratio of allowed versus dropped. So I'll just go ahead and specify that. Okay, and then I'll just go ahead and hit on run. And not much, doesn't give us much again. So that's it. So we see here that Athena allows us to do quite a lot of things in terms of analyzing what we've got within our S3 bucket that contains our VPC flow logs. All right, so that is where we are going to be stopping our conversation around Amazon Athena. So here is how each of the components of the architecture collaborates to give us an end-to-end log analysis solution. First, we've got the VPC, which is our virtual private network in the AWS cloud, where all of our resources, with the exception of the S3 bucket, resides. Of course, the VPC gives us the appropriate isolation that is necessary for our operations to stay secure. And then the VPC flow logs capture the metadata about every network flow within our VPC, which serves as a raw, unfiltered data reflecting how our resources communicate. And then S3 acts as a highly durable and scalable repository, storing the continuously generated VPC flow logs It's an object storage giving us cost-effective and long-term data retention solutions. And of course, before analysis can occur, the raw data needs structure. So AWS Glue automatically discovers the schema of our logs. It transforms and catalogs the data, making our data queryable. This is important to convert disorganized logs into a structured data format. And then Athena, of course, comes in as the analytical engine, allowing us to run SQL queries directly against our structured data, transforming raw log files into insights with very little overhead. So together, these components form a pipeline. The VPC and the VPC flow logs generate and capture the essential network activity data. And S3 safely stores the data while Glue structures and catalogs the data. Then Athena empowers us to interrogate this data in real time, enabling us to do some quick troubleshooting, to analyze the logs, and to perform optimization if that is necessary. So we see here that we've got an end-to-end architecture that ensures that every piece of our network monitoring puzzle is addressed, from secure data generation to insightful real-time analytics, which is going to be giving us a robust solution for managing and analyzing our AWS network traffic. So we've come to the end of the session. I hope you enjoyed yourselves. I hope you learned something new. If you've got any questions, go ahead and drop it in the comment section below, and I'll do my best to attend to all of the questions. Thank you again for watching. Thank you for being a subscriber, and see you in the next video.